Hello, everyone, and welcome to this Bakerpedia seminar on how vision inspection revolutionizes quality control in bakery products. I am your host, Richard Charpentier, and today we'll be showing you a slide of who we are. We are Baking Innovation. Who are we? We're a team of bakery experts who believe in art and science of baking, and we help industrial bakers and bakery manufacturers with product development, product efficiency, commercialization product, and new product development. So for any questions, please feel free to reach us at Baking Innovation or look us on our website at baking-innovation.com. This seminar is brought to you by KPM Analytics. KPM Analytics supplies instruments that measure critical quality parameters of incoming ingredients, analyze products during the baking process, and ensure final product quality. Their comprehensive range of analyzers are used by food producers throughout their production to improve efficiency, ensure quality, and protect their brand. KPM Analytics is backed by 100+ years of experience developing advanced products and processes for quality assurance and process control in baked goods manufacturing. If you need QA help, please feel free to check their website at kpmanalytics.com. Today, it's a great pleasure to be joined by Andrew McGee. Andrew has over 30 years of experience in the bakery industry. He has a Bachelor of Business from the University of Technology in Sydney, Australia, and joined the bakery industry in Australia in 1987. When Andrew arrived in the US, he joined Northeast Foods in Baltimore, working for the Paterkis family in the bakeries supplying McDonald's restaurants. Andrew then worked for High Pro System inspection systems for bakery products for 10 years, heading up the North American operations before joining Schaefer Mixers, a part of the Bundy Group, in 2017. In 2023, Andrew rejoined High Pro System, which is now part of the KPM Analytics Group, which includes iconic bakery equipment brands such as Chopin, SensorTech, Process Sensor, Slightline, and Unity. So now let's dive into vision inspection, and Andrew will now share a presentation. Thank you, Andrew, and welcome to the webinar.
Thank you, Richard. I appreciate the introduction, and welcome to everybody to the conversation. We will talk about vision and how that can help you in your business, in your bakeries. But and if you have any questions, please use the chat, and we will answer those at the end. No problem. I talk a little fast, so if I'm going too fast, put something in the chat to say slow down, Andrew. So as Richard mentioned, I've been in the baking industry a long time, and I've seen a lot of changes in that time. And technology has certainly helped a lot in bakery operations, especially where it's hard to get staff and hard to maintain good quality. I have worked with many challenging customers. I think we all have those that want very high standards and won't settle for anything less. And sometimes baking is a challenge. It's a natural product. It varies a little bit, and giving the customer exactly the same thing every time is a challenge. And I'm sure Richard knows that better than most. And so that's where vision can help you in that cause. So vision can be used in all these different applications. We have used them in all these applications and more. So cookies, muffins, buns, donuts, finished products like pizzas already topped, or just the pizza crusts as well. And the ability of vision to be able to provide you accurate information, and even on an online inspection system, 100% of the products are being inspected. So it really gives you a true picture of your process. Here's a graphic of a typical production line of, depending on what it is, but in this case, it's like a bun or a bread line. We have the different processes. We have a lot of inputs. We have the ingredients coming in, and then we have the process itself. You know, the mixing, the fermentation, the mixing, the forming, proofing, baking, and there's lots of things that can go wrong in any of those parts of the process. And KPM provides some tools that can help you check the quality of your flour as it comes in before you use it. And then there are many control mechanisms that are on the different steps in the production process. But Vision can help you to objectively measure the products throughout the process, but also at the end of the process before it goes to the customer. Some on this presentation, which you can get at the end of this discussion, there are some videos here, which are just videos that I've taken off YouTube, which just show different production processes for different products. So if you're working in a cookie bakery right now, you can see how buns are made, or you can see how crackers are made, or how donuts are made. So it just gives you a bit of an idea of the varying processes that are used in the baking industry that we're always trying to adapt to as far as our vision systems go. In bakeries, the most important thing, of course, from the baking perspective is quality of the product that we're supplying the customer. But we're in business as well, so we have to try and, while providing the best quality for the customer, we also have to have high efficiency and we have to be profitable. Otherwise, we won't be here tomorrow. So that's the balance, is always to make a good quality product, to control our processes so we minimize waste and maximize efficiency so that we can be profitable in the long term. There's a lot of challenges in the marketplace. Depending on which part of the baking industry you're in, your margins can be very slim. I know, for example, in tortillas, it's a very low margin product that has to be, so you have to be very efficient and minimize waste. In some other categories, where high-end pastries and products like that, you still want to be efficient, but at least you have a little bit more margin. But again, being able to understand your process and control your process and control your quality is critical for all of us. So there are, as we talked about before, there are a lot of different variables, and trying to control all those is very challenging. But at least with a vision system, we have the ability to look at the quality of the product that's coming off the line. Now, typically, if you haven't got a vision system right now, you're doing some sort of manual checks. I know when I worked in the bakeries in Australia, when we're producing buns, let's say for McDonald's, we would take 6 buns off the line every 10 or 15 minutes, and we would physically measure them. You may have a little station like this here where you're weighing them, you're analyzing the color, measuring the color, or subjectively evaluating the color. You're measuring the height of the product, the stack height of cookies or crackers. And then you're logging that, and that information is maybe being entered into a spreadsheet or to a statistical package, and you're generating some reports about what your process capability is. And I think the one thing that we found is that once we went to online inspection systems with 100% inspection, we kind of got a little bit scared. We went, oh my goodness, I thought our process was like this, but when I get 100% of the data, oh, I see our process is actually much wider and there's a lot more variation. The process didn't change. It's just now that I have a better picture of that. So vision can help you with a lot of the things that you're doing as far as evaluating quality. Certainly on measurements, and I'll come up to the next slide here. So measurements, we can certainly automatically measure products. There's no problem whatsoever. Visual, shape, color, appearance. On a baguette, we can see if the scores are there, if they're in the right location, if they're in the right angle. We can't really help you with sensory, I'm sorry. That's something that you will continue to have to do manually. We can also include some of KPM's other technology, being NIR technology, to be able to help measure moisture on cookies and crackers and other products as well. And over here on the right is an image of the inside of a standalone, like a benchtop inspection system, where you can run the products through on a conveyor. Again, you're still sampling, but again, you're able to collect measurements for more samples because you just put them on the conveyor, and the length, the width, the bake color, the shape, appearance, and even moisture can be automatically measured and logged and loaded into your statistical package for generating reports. There are also some additional capabilities with vision, especially an online vision system, that can be very useful to a baker. For example, again, talking about a bun bakery, where the buns are going down the line, and you might have somebody inspecting the products or looking at the products, but are they looking at the bottom of the product? And the answer is probably not. They might be turning a few buns over, but not really looking at the bottom of the product. We have an inspection system that allows us to actually be able to see the bottom of the product, every single bottom of the product. And here you are, you can see some images of the bottom of the product. You can see here, this one has got a little bit of dirt or grease on the bottom of it. The system can see that, and if you want to, it can reject it from the line. It also, the vision systems also have, using their very high resolution cameras, are able to detect some foreign material as well. So that's a very useful tool as well. Just giving you some basic fundamentals of vision. We are using cameras, and we are using a top color camera and a top 3D camera with a laser line. So we're getting a very detailed profile of the product from a height. Also, we're getting color measurements and topping measurements, how much toppings on the product, etc., using the color camera. But as I mentioned, we have a bottom color camera as well that's looking up through a gap in the conveyor, and we can see the bottom of the products as well, and measure the bake color, but also see any defects on it. I'm going to slip through these. You can see here, for example, this is some images of, this is a cookie with a little chocolate piece on top. So you can see we get a very detailed profile of the product, which allows us to measure height anywhere. We can measure max height, min height, edge height, whatever it is that really is something that you're interested in for your particular product. We can see the slope of the product. We can see imprints on the top of the product, and again, see if they're there or not. Then, of course, we have the bottom images here, and you can see here, this is the camera looking up from below that's looking through this gap. And as the products move across that conveyor, it's a line scan camera grabbing one row of pixels at a time as the product traverses the gap. So from that, you can see it puts together the image here of the bottom of the product. And again, we can measure that, the bake color, the diameter. We can see white ring on the edge as well. Here's a video of a cookie inspection system. And you can see here it's coming out of the oven under the cooling duct, and we have the vision system here. So here we have the camera above looking down and inspecting from the top. We have a camera below looking from below. As these cookies go across the gap, it's seeing the bottom of the product. And then we have a 3D camera. You can see that laser line there, the red laser line. So what we're doing is we have a camera that's over here looking at the laser line traversing over the product. We can also measure the height, the stack height, the thickness of the product, the evenness of the product. So I think that, okay. And then we have, in this particular system, we have a rejection mechanism. So after the 3 images are put together, and we analyze those images for each product, if there's a defect with the product, we have this rejection mechanism. So there's an array of air nozzles here, and then activate to reject just the bad product, the product that we want to have rejected from the system. This is a video of a bun inspection system. I'm going to move it along a little bit because we don't need to see all the ads. Here we go. So again, you can see that red laser line traversing the buns, so we can measure the height of the bun, the slope of the bun. You can see whether it's what the maximum height, the average height, what the edge height. Get a very detailed profile of the product. Again, I'm going to. This is the interface here. So the interface, you're getting some really detailed information. The amount of rejects that you're seeing, the percentage. This is for each individual measurement. You can see a histogram. Partial is for the last 2 minutes, and total is for the total production run. Here we save images of any products that are rejected, so that when a product is rejected, you can click on that image. It'll give you the measurements for that particular product, and it'll highlight in red the reason it was rejected. You can see there, some of those buns have a lot of white ring. We can see ongoing real-time measurements. This data can also be transferred to your statistical analysis package or reporting packages that you might already have existing in the bakery. And again, this is the bottom inspection camera. And then you'll see the rejection mechanism here. For different products, we have different rejection mechanisms. The key is just to reject the bad product, not the one next to it, not the one in front of it, just the bad product. So that is the insurance policy, to make sure the bad products don't go out to the customer. Again, I'm going to move it along a little bit. Okay, here's an example of some rejection mechanisms that you can see. Here we go. And this is just a sampling for lots of different products. We have lots of different ways to do it. So hamburger and cluster buns, we have this. So the rejected product is being sent to the 90-degree conveyor and taken away. So the product coming towards us is going away. Tortillas, we're just using an air nozzle and a gap, very simple system. On baguettes, we have a retracting conveyor. Down on the bagels there, we're putting double bagels one location and bad bagels to the other location, because the double bagels can be broken apart and still recirculated into the system. See here the baguettes with a longitudinal, the way they're traveling longitudinally, we can just have a declining conveyor for those. Okay, next slide. Sorry, guys. Again, this is just talking about the different cameras that we have. So this is one of our standalone systems, and this is an online inspection system. But again, the systems are designed, the online inspection systems are designed for your particular product. We have the capability on the online inspection, 100% inspection. We get a lot of data from the system. It's a very useful tool. And again, we talked about the ability to replace one of these manual stations with an online, sorry, not an online, an at-line unit, just running lots of samples through the system to collect data very quickly. Baking color, size and shape, volume. We can see out of shape products. We can see, and especially with artisan type products, which I know Richard has a lot of experience with, there's a lot of variation in shape that's actually good. And then there's some variation shape which is not going to be good because it won't fit into the package or something like that. So again, the system learns very quickly using some AI technology. Okay, which product, which shapes are acceptable and which shapes are unacceptable, and the system can automatically deal with that. Color, we can see splits, we can see toppings, lots of different things. This is the 3D camera system, bottom camera inspection. And again, this is what I was talking about earlier. As far as baguettes, we can measure a lot of different attributes. But again, the key for you is to decide what's important to your customer, and then we focus the vision system around that. Lots of things you can measure, but if it doesn't make any difference to your customer or to your process, let's not focus on those. Let's just focus on the important attributes. And that can be different for different products. So again, you have the power for one product to be looking at particular things like maybe topping or bake color, and on other products, you can be looking at shape and size, or you can be looking at all of them for all your products. Here's some pastry products, which again, we can be seeing, how well they're folded, if they're not folded properly, not properly formed. And again, sending an alert is the most important thing, so the issue can be addressed very quickly, but also then the defective product can be removed from the line. Color cameras, again, the resolution of the color camera is key. The higher the resolution, the more detail you can see. And again, this gives you an indication. This is using the 3 different cameras. The most high resolution camera we can see the defect very clearly, whereas over here on the left-hand side, it's not so easy to see the defect. Lighting systems on buns right now, glaze is a big issue. Lots of people are using glaze on buns. So to be able to accurately measure the bake color is hard because the glaze reflects a lot of light. So again, we've spent 2 years developing the technology to be able to do that, to measure glaze levels, but also to measure bake color at the same time. I won't go through this. Is just the different rejection mechanisms. We talked about that before, and you can see that yourself. It's just a couple of different types of systems that we have. This is a rejection mechanism for an Oreo type product. And again, the system is just opening the flaps up and the bad product is dropping down. You can see this in slow motion here. And again, the vision system is to the right, identifying which products need to be rejected, and then the system rejects it. In process control, we can also have multiple vision systems throughout the process, because looking at typically our vision systems before packaging are telling us, okay, what's the problem? But that might have occurred, 4 or 5 hours earlier up in the beginning of the product process, either in the forming area or you might have seen in the proofer. And so sometimes people are putting vision systems in interim stages to be able to see the problems as early as possible and then take corrective action. We also had the ability to automatically control different processes, either in the forming. In this case, we were automatically controlling the last 2 or 3 zones of a tunnel oven on a cookie line to be able to keep the bake color always within range. So it's like an ovensman that never goes on break, or an ovens person that never looks away. It can automatically control the oven, and we're being able to significantly reduce waste. User interface is very easy. You choose which attributes you want to use to decide to whether accept or reject a product, and you can actually then adjust the settings accordingly, the tolerances accordingly. And you can even do that while you're inspecting. So you see some products being rejected. Oh, no, these are okay. Let me go and make an adjustment to the rejection criteria. And you can do that real time. And then we have reporting, availability, sharing of data that I mentioned before. AI is the big part of what we're doing right now, being able to detect defects, that can be a bit challenging to see with just ordinary cameras. For example, I'll go here, for example, on this topped pizza here, this pizza looks fine, but what we see is we have some defects that are on that pizza, but because the color of those defects is very similar to the product, the ingredients that are going on that product, it's very hard to see that using traditional vision. But using hyperspectral imaging and some AI analysis, we can actually see these defects even though they're the same color. So this is a piece of white plastic, but we can see it because using hyperspectral, we're not using the visible spectrum, we're using infrared and near infrared. The system can actually see that the spectral fingerprint of that particular reflection of that near infrared coming off that product is different from the food, and it distinguishes it from the food. So it's a very great food safety tool that can be used. We can also see here that on using AI, we can see quite clearly whether something is properly topped or not properly topped. Here on animal cracker cookies, we can identify that this product is an elephant, and so it's an elephant. Hold on, it's missing a foot. So again, AI is proving to be very helpful in being able to measure and detect defects. Here, for example, this is in a poultry application. Seeing clear plastic or white on a white background was always very challenging. AI has made it much more feasible for us to be able to do that, to be able to see things that really the human eye would struggle to see. So in summary, vision inspection systems can help you to automate your inspection process. It's objective. It doesn't matter whether it's Andrew or Richard looking at the product. The machine does not have an opinion. It just does what you tell it to do. It gives you real-time information so you can see what's happening right now and take action straight away. It also can help you to save labor. And it also gives you so much information about your production process. You really understand when something changes, you can see how it changes your finished product quality. So it's a really powerful tool that can help you to produce high quality products, but also reduce waste and improve profitability. I'm done.
Well, thank you, Andrew. That was remarkable. It's something I've worked with in the past too, and it's unbelievable the amount of defects you can catch in your system, and reinforces, all throughout the line from, like you said earlier, from the mixer on to correct the issues as you see it more and more. And then I remember working on a project years ago when I worked for AIB, where they implemented something like that with Dr. Dempster for Burger King, and I was just helping out. But it's a great tool, and I think quality and consistency is a key to bakery growth. So good presentation.
So typically, obviously, when the system's first set up, we're doing a full calibration and checking the system out to make sure that it's measuring accurately. But we provide each customer with what we call calibration blocks. And so depending on the product, they're usually shaped something similar to the products that you're using and the similar height. And so what the idea is for calibration, you're just running the blocks through periodically, however often you want to. We do encourage you to do it more often rather than less often, because that way, if the calibration blocks, when you run them through, the system measures them and checks them and says, okay, are the measurements I'm measuring on these test blocks matching up with what I expect them to be? If the answer is yes, everything is good. If the answer is no, then okay, something's going on here. What is it? Have I not cleaned the cameras? Have I not, or is there something actually wrong with the system? And so we encourage you to do it very frequently, just so it's a very quick process, takes 2 or 3 minutes. And the reason we encourage you is that once you've run the test blocks through and everything's okay, you can feel confident that everything is being measured accurately. If you haven't run the test blocks for a week or for a month, oh, gee, okay, and somebody looks at a product and says, well, why is this being rigid? It's when, you look at the image and it says it's too tall. Well, this looks okay to me. Oh, yeah, blah, blah, blah. Whereas if you know that that morning the test blocks will run through the system, you can say, yeah, we calibrate the system this morning. That's measuring accurately. And so that's usually what's required from a calibration point of view. If when you run the test blocks through, there is a red flag because it gives you an alert to say, hey, this is not quite right. It'll give you a list of things to check, make sure the cameras are clean, make sure the light's on, blah, 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 the lights are clean. And then if you do that again, you can update the calibration based on you running those products through the test blocks through the system. So it's very simple, should be done pretty frequently. But again, usually there's not any issue. But if there is an issue, you want to know about it so you can get it addressed. Yes, absolutely. So there are a couple of ways that we can do that. We can use AI to look at, acceptable shapes and unacceptable shapes. But the system also, for example, on a bun, will measure diameter, and it'll measure min diameter, max diameter, average diameter. And really, one of the things that we look at is roundness on buns and round products, or round, biscuits, cookies. So the system, and again, we work with the customer to define how it's going to be calculated, but our standard calculation would be to say the minimum diameter divided by the maximum diameter gives you a percentage roundness. So for example, on a tortilla, if it's 9 inches on the short diameter, 10 inches on the long diameter, 9 divided by 10 says, okay, this product is 90% round. And then you can set a percentage to say, okay, I want it to be more round or less round. So you can do it that way. So there are a couple of different ways to address it. So depending on the nature of the product, artisan type products, we're usually looking at the overall shape. And as I say, you're designating good shapes, bad shapes, and the system learns those and uses those going ahead to compare against the actual production to decide whether something's acceptable or not. But yes, it's absolutely possible, depending on your product, how we calculated it. Absolutely, yeah. That's a very common question we get asked. So yes, because that's on chocolate chip cookies. That's one of the key features, that you want the chocolate chips to be, number one, visible, but also pretty evenly distributed through a batch. So yes, the system can count what's apparent in the surface, not what's inside, but certainly what's in the surface. And you can set some numbers. You can say, okay, I need to have a minimum of 3, and you might set a maximum, but you might not set a maximum. And it can give you a trend graph of, okay, the number of chocolate chips that it sees in the surface of each product. For example, in pizza topping lines, the number one complaint in the US is, you guys can guess it, I don't have enough pepperoni on my pizza, or the number of pepperonis on my pizza is not the same as shown on the box. So that's a big thing for those guys. So we're physically counting the number of discs on the top of and they set a minimum and a maximum. Usually it's just a minimum, because they don't want to send a pepperoni pizza out that doesn't have enough pepperoni on it. And also it's important too, because maybe there's a problem with the pepperoni slicer, or in the chocolate chips, maybe they're not adding enough chocolate chips, or maybe they're not getting very, very well incorporated. You maybe need to mix a little bit more, or something like that. It's not very hard, but it's not a black box that you can plug in and walk away and it'll work no matter what. It does require, obviously, we work with you to set the system up for your products, for your range of products. And then if you add a new product, we can work with you to add that new product. But bakery, as we know, is a vary. It's a live product, live yeast in a lot of products, so it does vary a little bit. So the system can be set up to deal with, obviously measurements and things like that are pretty straightforward. But when we start to look at very subtle defects, like on a bun, when we're looking at blisters, sometimes the background color of the bun or the bread loaf, especially in an artisan loaf where it's very uneven color, sometimes can be changing a little bit, and as it changes a little bit, that might make it more or less difficult for us to see a blister or a blotch or something like that. So typically when we go into a facility, we're asking to have a couple of what we call key users that can be trained to a higher level, so that when things are changing a little bit, they can be adjusting the tolerances just a little bit on some of these very subtle measurements that you might, or defect detections that you might want to do. That's a good question. We've never done it. I'm sure it's possible, but the high temperature environment of the oven makes it a challenge. We've done camera systems straight outside of the oven, and that's not a problem, even though that's a high temperature environment. We enclose the cameras in an air conditioned cabinet and seal it, and so straight after the ovens we can do it. We've never done it inside the oven. I believe it would be possible, but again, you have to have a specific camera to be able to do that, and that would be challenging for sure. We really haven't met an application that we haven't been able to do. So on cookies, we're doing 5,000, 10,000 pieces. Especially if they're small cookies, it can be coming quite fast. Pieces per minute, no problem. Typically, other applications, buns and things like, buns are doing, 1,000, 1,400 pieces a minute. That's no problem whatsoever. Loaves, we can easily keep up with that. The only time we've had some challenges, we've still been able to do it, but if the conveyors are running super fast. So for example, on a tortilla line, conveyors can be running at like 210 or 250 feet a minute. And we can still do the inspection, but if it's going much faster than that, it can be a challenge to get accurate measurements. We can still get measurements, but they may not be quite as accurate as when you're running slower. But again, we really haven't had an application that we've said, oh no, that's too fast, we can't do it. We've always been able to do it. So I don't think we would have a chat. Depending on what your product is, I'm sure we would be able to inspect 100% of the products coming off the line. Yes, so that's when I was talking about vision process control. That's typically, we can have a vision, for example, in the forming area. For example, a good example is like in pizza crust, where the dough is pressed out. The ballers comes and it's pressed out. We often have an inspection system straight after the press, looking at the product before it goes into the oven, because we can see straight away there any misshapes, as somebody mentioned earlier about oval shape. We can see if they're already oval, or we can see if they're not properly pressed, or we can see if they're not the right size. So we can see that immediately and then set off an alert so that somebody can take corrective action. We've also done a lot of feedback loops in different applications as well, so that we can see that the product being pressed, because maybe the dough's changed a little bit. It's a little stiffer, doesn't have as much water, or it's a little softer. Maybe it's pressing more or less and the shape's not quite right. We can set off the alert, but we can also automatically adjust the press as well. So that's something that we've done as well. A little bit more complicated, and it takes a little bit longer to dial in, but it's absolutely doable. And we've done the same, as I mentioned before, in ovens, controlling the bake through an oven. Sesame seed topping on buns, we can see the seed going onto the product after the proofer, and then or the poppy seed or whatever, and we can actually flag it immediately if there's an issue, one of the mandrels is blocked or something, or we can automatically adjust the flow. So yes, there's a lot of, that's really the future for us, because the challenge is also, how do you adjust to those changing conditions? For example, the oven control, when we first started doing that, or when I first did it in my baking career many, many years ago, the system kind of pecked. We said, oh, it's too light. Oh, turn the oven up. Oh, it's too dark. So we'll go like this. And that's where some AI algorithms over the last 10 years, 15 years have really helped us, because it gives you a much smarter way to respond to the data that you're seeing, and you can analyze much more data much more quickly and take a better response to it. So it's proving to be a very powerful tool for us in these feedback loop situations. So for a bread loaf, typically, when we have an online inspection system there, we're again inspecting the loaves. We have lines where we have after the proofer to make sure the product's been proofed properly. We have it after the oven to make sure it's baked properly, and then we have before packaging. Excuse me. But then, so what we're measuring there, we can measure, the volume of the product, the height of the product, the bake color, the length, the width. We can see dark spots, light spots. If we're looking at the bottom of the product, we can see any carbon or grease on the bottom of the product. So there's lots of things we can measure. And again, usually I know you guys are working to some sort of specification for your product. And again, those can all be programmed in. I'm not sure I answered your question, but hopefully I did. Yeah, length, width, height, we can measure that and we can calculate volume. And depending on the product, often what we've used the volume to be able to estimate the weight, because we know that in all baked products, weight is always something that is of concern. Sometimes you need to meet a minimum weight standard. So if the product is pretty consistent density, the volume can be a good estimator. It's not 100% accurate, but it's a good estimator of weight. Some products, it doesn't work so well. For example, products that are very airy and open, well, like a ciabatta, that could be very challenging to actually use the volume to accurately measure the weight. But on products that are some cookies that are very, consistent density, yeah, when we measure the volume, we can get a pretty good estimate of the weight. Some health food bars, things like that, we can measure the volume and get a reasonable estimate of the weight. Yeah, so for example, depending on the type of oven you have. So for example, if you have a tunnel oven, we can be measuring the product across the whole oven band as it comes out. And again, you can see whether it's lighter on one side, darker on one side. The data is given to you based on positions on the oven band, and so you can see that, okay, if there's something not quite right. For a conveyorized proofing oven for buns and things like that, it's giving you the measurement, but again, it's a little harder in that type of oven to be able to see hot spots and light spots. But in a tunnel oven where it's left to right, it's very easy to see that. Or a swing tray oven, for example, you can see that the products on the right, for example, are always light, and the products on the left are a little bit darker. So you can straight away see that that's an issue. Okay, we haven't really got to that point at this stage, no. So typically we would recommend something like our Chopin technology, which that allows you to actually take a piece of the dough that's been mixed and put it into the Chopin, which then sort of checks the dough rheology. On a straight vision, yeah, it's very hard to really know just using visual cues whether a product, whether a dough is properly developed. I mean, I guess you can see it pulling away from the walls of the mixing bowl and things like that, but it's very challenging. We haven't been able to do that, to be quite honest with you. But I know, as I say, the dough rheology side of things that Chopin provides, there's a lot of tools where you can take, you can take dough from the mixer, you can take dough from after the proofer and put it into the Chopin equipment and be able to get a comparative measurement against compared to what your target is, whether the dough is properly developed, whether it's performing satisfactorily. No, I mean the one thing you have to do is to keep the optical windows clean. So it's like when I have my glasses and they're not clean, I can't see things. So we have the upper cameras, color camera and 3D camera. They just need to be kept clean, and they're enclosed in a cabinet, and the optical window just needs to be kept clean. Typically for the upper cameras, once a week is more than enough to keep them clean. The bottom camera is a little bit more challenging because, as we know, dirt falls down. Gravity is a terrible thing. And so it'll often end up on the optical window. We have angled the optical window so that a lot of it falls off. And then we also have air curtain or air nozzles blasting the optical window. So it does keep it fairly clean, but as you know, some of the things that are coming off, have oil and grease in them, and sometimes they can sort of stick a little bit. Sesame seeds, for example, create a little bit of oil. So what we're saying typically for a bottom window, we need that wiped at least once a day and sometimes once a shift, just because there's a lot, especially in a very harsh, dusty environment. Other than that, the system's run by an industrial PC. It is a piece of equipment, stainless steel enclosure. And it's just conveyor. Other than that, it's just conveyors with a digital encoder to track the products, and so we get very accurate measurements. So there's nothing too sophisticated about it, but keeping the optical windows clean and the lights clean is probably the key thing that needs to be done, as I say, at least once a week for the upper cameras and lighting systems, and then once a day for the lower camera.
Perfect. Well, thank you very much, Andrew, and KPM Analytics for sponsoring this informative session on vision inspection. Quite a lot of great information. Thank you again, everyone, for your time. And we hope to see you in another Bakerview very soon. Until next time, happy baking.